Good afternoon, everyone. Welcome back to College Algebra, and this is hopefully that this is the last video. And I don't know that do we need to do anything else. I don't think so. We cover like almost like 98% of the curriculum. There's only 2% left, but I don't think it's really important, and because you guys know that we've been falling behind about more than a week, so I kind of throw that away. I already told you in the email. Okay, so this is the last video. Maybe if we have time, then I'll give you another video about doing some more exercising regarding solving exponential equation or maybe a log equation. So in the previous video, you guys already learned what a logarithm function is. In this video, I want to talk about how to solve logarithmic equation. Okay. As you know, that logarithm function is the curve represented by the curve, right? And that curve, it never it always cross the x-axis, and when it's crossed the x-axis, it means that they have the x-intercept point, and when it have an x-intercept point, it means that the log equation has solution. Okay, and the strategy to solve a log equation is kind of the same as we solve exponential equation. We also use the property. We use the logarithm principle, and the most important thing that we also have equivalence properties. You remember when we learned how to solve exponential equation, the equivalent properties say that if we have the base the same, we can set up the exponent equal each other, right? So for log equation, if we can convert some way somehow so that the base of the log the same, then we can set up the argument of both sides equal to each other. Okay, so let's get started. Log equation. Okay. And again, there are two general strategies to solve log equation. The first strategy is to use equivalence property. Equivalence property. And equivalence property state that if we have two log and the base is the same, we can set the argument equal to each other. So if log base b of x, okay, x is the argument, b is the base, equal to log base b of y. See, you have two log on both sides, and the base is the same, c base b, then this is imply x equal y. Okay. This is equivalence property. You know, the equation could be very hard at the beginning. However, you need to bring it back to this form. Okay, or you have to bring back to the form that you can apply the log principle. Okay. Example. Example. We have log base 2 3x minus 4. Excuse me. Đấy, muốn ngồi đó đi. Cái video làm gì nữa? Okay. Equal to log base 2 x plus 2. Okay. So in this example, this is very simple. You see that the base is the same already, right? Okay, if the base is the same, when we have two log on the left hand side and the right hand side, you see that it's the same as the form equivalence property form. Then we can set up the argument equal to each other. The argument is 3x minus 4 equal to x plus 2. Okay. Okay, 3x minus 4 equal to x plus 2. Then you see that it becomes very simple equation. Then you subtract both sides by x. Okay, then x equals 3. Okay, I don't need explaining how to get the answer over here anymore, because this is the very basic linear equation. You guys already learned the intermediate algebra, so I'm not gonna go ahead and explain how to do it. You just isolate all the x and isolate all the term without x to right hand side by both sides by 2, then you get the answer here. Okay, and again, as any other equation, every time you get the solution, you need to bring it back to check if the answer is correct or not. Okay, so you plug it in here, right? So 3 minus 9 and minus 4 is 5, right? 3 over here, 3 plus 2, 5, so it is same. Okay, it means that the equation is satisfied. Okay, so that is a typical example of how to solve equivalence property to get the solution for the logarithmic equation. Of course, as I told you, that the equation is not always as simple as this one. It could be very complicated. It could be kind of pretty complicated. Depends on how they give you the question. However, the general strategy is to try to get to this form, to the form that where you can apply the equivalence property. Okay, I can give you something example, something more, a little bit more complicated, but it's kind of the same thing using the same equivalence property. For example, I have natural x minus 4, okay, natural log equal to, this is another natural log, equal to x plus 6, okay, minus L1x. Okay. Okay. So the difference between this example and that example is that we have only two log, and this log base 2, we have log, natural log, I mean log base e. However, in this example, we have 3 different log. 3 log, not the same log, but we have 3 log. 3 natural log. Okay. So, in order to solve this equation, you have to bring it back to this form. Okay. The base must be the same. Luckily, we have the base the same already, because every time we have natural log, the base is e number, right? So the base is the same already. However, if we apply this form, we see that there are only 2 log, and we have 3 log. So what should we do? What should we do to bring it back to 2 log instead of having 3 log? Okay. In a previous video, I also talked about some property, right? Remember, when we add 2 log together, or we subtract 2 log together, it gives you a product of the log of the product and the log of the quotient. So if I move this log over here, okay, to the left hand side, so become positive log, right? And to this log, I keep it on the left hand side. Okay, and now I add 2 log together, and if you add 2 log together, it gives you the product. So it gives you ln of x times x minus 4. Okay, over here give you ln x plus 6. Okay, now I successfully bring it back to 2 log. Now I can apply the equivalence property, because the base are the same. Base is over here, the base is the same, so I can set up the argument equal each other. Okay, argument equal each other. Now it becomes a very simple equation. So we have x squared minus 4x equal x plus 6. How are we going to solve this? Okay, don't tell me that you guys don't know how to solve this. What kind of equation is this? Anyone? Quadratic, right? Look at this square right here. Okay, so we need to bring it back to standard form, right? So we have x squared minus 5x minus 6 equals 0. Now we have quadratic equation. Everybody know how to do this. You just need to factor. Alright. So you have x over here, you have negative 3, you have negative 3, you have you have 6 plus 1 equal to 0, right? Factor that way. There you go, you have x minus 6 equal to 0, or x plus 1 equals 0. Then you have x equal to 6, and x equal to negative 1. And again, you have look like you have two solutions. However, you need to check which one satisfies. You always have to check, remember, okay? So 6 over here, 6 minus is 2, right? 6 over here, 6 plus 6 is 12. Okay. Over here is 6. Okay. So you have ln 12 minus ln 6. Is it equal to ln 2 or not? Okay, you can use calculator. Okay, to check if the answer is correct or not. Okay. After you plug into calculator, I see that 6 is satisfied. However, negative 1 doesn't work, right? Because think about it. Negative 1, you plug it in here, you have a negative ln negative 5. Remember, we don't have log of negative number. We cannot do it. Plug into calculator, doesn't work for the negative number, so this does not satisfy. So we have only one solution. Okay. Okay. So another strategy to solve a log equation is we use the log principle. Okay, it's a log principle. So second way, using log principle. And what is log principle? Anyone remember? Log principle say what? If log of base b of x equal y, then it's equivalent to x equal to b to the y. Remember? I already give you guys this formula last time, so we're gonna use this formula to solve a log equation. Okay. The thing is that sometimes the question is not really obvious, you know. What I mean over here, that it's not simple so that you can apply the equivalence property or the log principle right away. You know, you have to manipulate, convert some way, somehow, so that you can apply the log principle or the equivalence property. Okay, I'm going to give you something like that later. Okay, but before doing that, I'm going to give you an example how to use the log principle to solve for log equation. For example, I have that. Okay, what if I want to solve this equation for log base 3? Okay, every time I write a base, I write it lower than the log, right? And smaller, the number is kind of smaller. 2t minus 7 okay, equal to 8. Alright. Okay, so in order to use the log principle, first of all, you need to check if the question is in this form or not. Okay, let's investigate if it is in this form or not. If it is in this form, then we can apply the log principle. Okay, first of all, we check, okay, we have one log here, we have only one log here. Okay, we have the base b over here, the b is 3. kind of the same, right? The argument over here is x, our argument over here is 2t minus 7, my y is 8. However, we have an extra number 4 here, right? But in front of the log, we don't have anything. So in order to apply the log principle, we need to get rid of number 4 so that we don't have anything in front of the log. So this is 4 times. In order to get rid of number 4, what we do? This is multiplication, right? In order to get rid of multiplication, divide by 4 and divide by 4 too. And now what? Now what? The y value is not 8 anymore, right? The y value is 2 now. These 3 argument is 2t minus 7. The question is, isn't it this form yet? Yes, right? It's in this form. Because it's in this form, we can apply the log principle. So it's equal to x. X over here is 2t minus 7, the argument. So you have 2t minus 7. You kick 3 up, raise it to the y. The y over here is 2. 3 squared, right? So you have 2t minus 7 equal 9. So you have 2t equals 16. T equal 8. And of course you have to plug them back in to check your answer. And the answer is correct. Okay, remember, always have to check. Okay. There you go. So that is the way you apply the log principle when you solve a log equation. Again, it's not always simple as this one. This is very simple log of equation. Okay. Alright. Let me give you another one. Okay. This one you have to manipulate a little bit before you apply the log principle. Whatever have log base 2x equal to log base 2x equal to 3 minus log base 2 base 2 x minus 2. Alright, so in order to apply the log principle, we need to have only one log, but we have 2 log. So we need to combine the log, and we use property we learned in the previous video to combine the log. So add both sides. I bring back the log over here to the right hand side, so become positive. Okay, number 3 and keep it there, right? Number 3 and keep it there. And if you have 2 log added together, it'll give you the product, right? You already learned the property, so give you log base 2 of x times x minus 2. 3. Now the argument is everything inside the bracket. Okay, the argument x is everything inside the bracket. Base b is 2, y is 3. Okay, now I can apply the principle. Because in front of the log over here, there's nothing, right? So we count x minus 2, 2 to the 3rd power, right? I kick them up, right? I raise it to the 3rd power. Okay. Oops. Okay. Alright, so I raise it to the 3rd power, so you have x minus 2 raised to the 3rd power will give you 8. Okay. Now, how are we going to solve this equation? Of course, everybody knows how to solve this equation, right? Very simple equation. Yeah, every time you see the parentheses that are distributed, give you x squared minus 2x equal 8. Now what we have? We have quadratic equation. Okay. And everybody knows how to solve quadratic equation. Give you what? X, negative 4 plus 2 equal to 0. And x plus 2 equal to 0. Using the product property. The 0 product property, x equal to negative 2, x equal to 4. Then x equal to negative 2 doesn't work, right? Because x equal to negative 2, it means that we have log base 2 of negative 2 again. We never have log of the negative number, so we know that this doesn't work right away. And after I plug 4 into that, okay, 4 minus 2 is 2, log base 2 of 2 give you 1, 3 minus 1 is 2, log base 2 of 4 is 2 squared, So it's also give you 1, so this satisfies. Okay, then you're done. Always have to check. Okay. Okay. So that is the method of using the log principle to solve a log equation. As I told you in the previous video, I said we can also use a log function to solve exponential equation. You remember I said that is the second method of solving exponential equation. So in this video I want to do some example of how to solve exponential equation using log. Okay, because sometimes we must use log to solve exponential equation. We cannot use equivalence property. Okay. Okay. Using log function to solve exponential equation. Okay. The strategy of solving exponential equation is to get the base the same, but that's the first strategy. The second strategy, when the base is not the same. Okay, when the base is different, or when the base that some way somehow we cannot convert it to be the same, then we have to use log function. For example, I have something like this. I have 4 raised to the 2x minus 7, okay, equal to 5. So this is no log, okay, this is exponential equation now, equal to 3x plus 1. Okay. So the first things, on the left hand side, see the exponent is 2x minus 7, and say on the right hand side the exponent is 3x plus 1, the base 4, over here the base is 5. And no way we can convert some way somehow so that the base over here the same. So if you see that case, okay, if you see that case, you have to use the log. However, we learn so many log. We learn natural log, we learn log base 10, we learn log base 2, with 3, with 5, you know. So it doesn't matter what base you want to use, you can use log base natural log or log base 10. Most of the time they use natural log, so I'm going to do natural log. So I'm going to take natural log both sides, okay? Okay. So after you take natural log both sides, you apply one of the property I already showed you last time. You remember the property is log base b of a to the c equal to c log base b of a. I bring c to the front. C is the exponent, so over here 2x minus 7 is the exponent. So I bring it to the front. So I have 2x minus 7, bring it to the front, so ln 4 left, right? Okay, same thing over here. I have 3x minus 1, bring it to the front, and I have ln 5 by using this formula. Okay. Then I distribute it. I have 2x ln 4 minus 7 ln 4 equal 3x ln 5 minus ln 5. And I combine all the term with x together. So this is the term with x, this is another term with x, right? Alright. Then I combine it together. So I have what? 2x ln 4 minus 3x ln 5 equal to ln 5. I bring 7 ln 4 over here. Then I need to solve for x, but x is same common, so I factor x out. So I have 2 ln 4 minus 3 ln 5. I factor the x out, okay? So what I have left is 2 ln 4. I factor the x out. What I have left is 3 ln 5. Okay. Now in order to get x, what we need to do? What we need to do? In order to get x over there, I just divide it, right? So in order to get x, I divide both sides by 2 ln 4. Okay, 2 ln 4 minus 3 ln 5. And that's it. You're done. You get an x value. You will see the answer look very complicated, but it's not really, because when you plug into a calculator, all of this is a number. So you can plug into calculator L4, L7, you know, to get the number, but you don't have to. You can leave it like this, okay? So all I want you to remember is when you see the exponent, the base is so much different that you cannot bring it to be the same, then you have to use this method, which is apply log both sides of the equation, okay? And you have to use this formula also. Then remember that we have two terms with x, then you have to factor the x out, okay? Then everything becomes very simple, okay? Let me see if I miss anything. No, it's a plus. I'm sorry. So it's a plus, guys. It's plus. The formula, the question is plus. So the plus. Okay, L5. So this is plus. Okay, so this is L5. 7 L4 and L5. Okay, this is L5 plus, and this is L5. Sorry. There you go. Okay. Alright, so I think that's all for log equation. It's kind of very short video. Again, if I have time, then I might give you another video doing more problems, solving more, solving harder log equation. But for this video, I just show you the strategy and how to use the principle and equivalence property to solve a log equation. Then yeah, so if you guys have any question, let me know. It's not really that hard, but I hope that I have time to give you another video to do more practice on log equation and exponential equation. Okay. Yes, and this is the last video already. Hopefully that you guys can learn something to prepare for your future in this course. And I wish you luck on test number 3. Again, don't hesitate asking me any question before the test or the final exam, okay? I'm gonna do the final exam and post on as the announcement very soon. So, and I see you hopefully next semester. Bye bye.